So this is the unit circle. So we're going to start with degrees first, and then I'll show you the radians. This is 0 degrees, and this is 30 degrees. This is 40-degree angle, about 45-degree angle, excuse me, 60-degree angle, okay, 90-degree angle. And then when you go to the opposite side, that's going to be 180 degrees. And if you go all the way around, that will be 360 degrees, full circle. Well, 90 more than 180 is going to give you 270 degrees at the bottom. Okay. Now, this point here is 30 degrees less than. This point here is 30 degrees less than 180, so it'll be 150 degrees. And this point here is 45 degrees less than 180, that would be 135 degrees. And this point here is less than 60 less than 180, so that would be 120 degrees. And this point here is 30 degrees more than 180, so that will be 210 degrees. And then this point here is 45 more than 180, which would be 225 degrees. And this point here is 60 degrees more than 180, so that will give you 240 degrees. And that's 270. Now let's get to the fourth quadrant. Okay, this point here is 30 degrees less than 360, which is 330 degrees. And this point here is 45 less than 360, which is 315 degrees. And this point is 60 degrees less than 360, which is 300 degrees. Okay. So, this is the unit circle in terms of degrees. And the reason we call it the unit circle is the distance from the center to the edge. The radius of this circle is 1 unit. Okay, so that's 1 unit right there. And then this will be -1. Okay. And this will be +1. And this point here will be -1. That's why it's called a unit circle. It's 1 unit of radius. Okay. Now I'm going to rewrite everything in terms of radians. Okay, so you have to actually look at it in terms of radians rather than degrees. Okay, so 0 degrees is the same thing as 0 radians. Okay, that doesn't change. So I'm going to put radians in parentheses. 0 radians. 30 degrees is the same thing as pi/6 in terms of radians. And then 45 degrees is the same thing as pi/4 in terms of radians. And 60 degrees, same thing as pi/3 in radians. And 90 degrees is pi/2 in radians. And 180 degrees is pi in radians. And 360 degrees is the same thing as 2 pi in radians. Of course, 270 then will be 3 pi/2 in radians. Now, let's figure out the other angles. Okay, since this is 1/6 less than a pi, so this would be 5 pi/6 in radians. 5 pi/6. And since this is 1/4 less than a full pi, so that would be 3 pi/4. And this is 1/3 less than a full pi, and that will be 2 pi/3 in radians. Okay, now when we get 210 degrees, okay, this is pi/6 more than a pi, so that will be 7 pi/6. And this is pi/4 more than a pi, so it'll be 5 pi/4. And this is pi thirds more than pi, which is 4 pi over 3. Okay, now let's get to the fourth quadrant. Okay, this angle here is pi sixths less than a 2 whole pi. 2 whole pi is 12 over 12. So it'll be 11, excuse me, 2 whole pi means 12 over 6. So 11 pi over 6. And this is pi fourths less than a 2 whole. 2 whole is 8 over 4. So it'll be 7 pi over 4. And this angle is pi related to pi thirds, so 2 whole pi will be 6 pi, will be 5 pi over 3. Okay, now these are the angles both in degrees and radians. Okay, now we are going to take this unit circle and we're going to drop a perpendicular to the x-axis. Okay, since that angle is 30 degrees, this becomes a 30-60 right triangle. So let's take a look at 30-60 right triangle from your geometry. Okay, so the distance from here to here is 1 unit. Okay, so that's the radius, so that's 1, and that's 30 degrees, and that's right angle, and that's 60 degrees. Okay, on a 30-60 right triangle, the short side is half of the hypotenuse, so it'll be 1/2. Okay, what about the long side? Well, the long side, we can prove that using a Pythagorean theorem. So if we go a squared plus b squared is equal to c squared, okay, this now will look like 1/2 squared, okay, plus b squared is equal to 1 squared. This is 1/4 plus b squared is equal to 1, and b squared is equal to 3 over 4. Okay, and then when I take a square root of that, I'm going to get b is equal to plus or minus rad 3 over 2. Okay. So what that means is this side right here is either plus or minus rad 3 over 2. Okay, plus or minus rad 3 over 2. Since it's going to the right, this will be positive rad 3 over 2. And that is 1/2. So therefore, this point right here can be represented as the x value from here to here is rad 3 over 2, y value is 1/2. So I write x first, which is rad 3 over 2, and then I write the y value, which is 1/2. Okay. Now, if you were to drop perpendicular for the 60-degree angle, this is now 60, okay, and then this would be the 30. Okay, only thing that changes is this is my 1/2, from here to here is the 1/2, and the height is going to be rad 3 over 2, so my x now becomes 1/2, and my y becomes rad 3 over 2. Okay, the only thing that's left is a 45-degree angle. And let's construct a 45-degree angle. So this is 45-degree angle, which is in the middle. If I drop a perpendicular, that's my 45-degree angle. So if I have a 45-degree angle, both my height and the width is going to be the same. So that is 90, and that's 45, and that's 45. Okay, that's 45. Okay, and that's 1. So if I call that x, I'm going to call that x. Okay, I can use the Pythagorean theorem. X squared plus x squared is equal to 1. That's 2x squared is equal to 1. And that means my x squared is equal to 1 over 2. My x is equal to plus or minus. Okay, rad 1 is 1 over rad 2. If I rationalize my denominator, multiply top bar by rad 2, okay, this now becomes x is equal to plus or minus rad 2 over 2. So both the x and the y, this is rad 2 over 2, and this is rad 2 over 2. So since this is in the first quadrant, my x from here to here is rad 2 over 2. My y from here to here is rad 2 over 2. So I'm going to write this point as rad 2 over 2 and rad 2 over 2. Of course, this point here is x is 0 and my y value is 1, so 0, 1. Right? And let's get the corners and then we'll come back and do the other ones. So this one here, my x is negative 1 and my y is 0. And then here, my y is negative 1, my x is 0, so that's my point. And then I have one more. Oops. So, I have one more which is right here. Okay. And since that is 1 for the x value, so this point now becomes 1, 0, x is 0, y is, x is 1, y is 0. Okay. So I have triangles on this side. This triangle is exactly same as this triangle here. So this and this triangle are exactly the same. Only thing is, my x value is negative and my y value is positive. So for this point right there, it will be exactly same thing as that point, except this will be, x will be negative. So if I were to write this point, okay, let me make some room right here. It's getting pretty crowded. My x would be negative rad 3 over 2. The y is 1/2. And then, let's back that up a little bit. So x is negative rad 3 over 2. Y is 1/2. And that's that point right there. How about that point? That's going to be exactly the same point as this, except my x is going to be negative. So this is going to be negative rad 2 over 2. Okay, and the y is positive rad 2 over 2. And that's that point. And of course, this point is same as this point up here to the right, because that's that same triangle that I have here. So this point here will be x will be negative 1/2 and y will be rad 3 over 2. Alright, so in the first quadrant both x and y are positive. In the second quadrant x is negative, y is positive. And they have a third quadrant, which means this triangle here is same as this triangle. So both will be negative, so might as well write those out. So both x and y are negative. They're still the same as that point right there. So negative rad 3 over 2 and negative 1/2. And this triangle here is exactly same as this triangle. Both x and y are negative. So that point can be expressed as negative rad 2 over 2, comma, negative rad 2 over 2. Of course, that point can be the same thing as this point up here, okay? And so I can write except both x and y are negative, so it'll be negative 1/2, comma, negative rad 3 over 2. In the fourth quadrant, okay, I'm going to the fourth quadrant now to find these points. Okay, both but x is going to be positive and y is going to be negative here. So in the fourth quadrant, this point now, okay, this point right there, well, it's the same thing as this first point, okay, except I'm going to have a rad 3 over 2, comma, negative 1/2, and then this point here is same thing as my second point, except my x is negative. So it would be negative rad 2 over 2, and y is rad 2 over 2. And of course this point is same thing as that point right there. Okay, and then that will be, x will be negative 1/2, and then y would be positive rad 3 over 2. Okay, that is the unit circle related to 30, 60 right triangles from the trig and a 45, 45 right triangles. Okay, that's how they're related. They're connected to each other. Now, the only thing you need to know is we call this x and y. Okay, x and y, but in trig we call the x the cosine. So cosine of some angle, we call that. So cosine, let's say cosine of some angle, we'll call that theta. We call that x, and then sine of angle, we call that y. So first value is a cosine, second value is sine. So the point always be written as a cosine. Instead of using theta, let's just use x. Cosine of x, comma, sine of x. Okay. Cosine is the horizontal, okay, and then sine is the vertical. So cosine goes right and left, sine goes up and down. Okay. All right. Now, that is the unit circle. You need to copy that down. Okay, and then I'm going to show you one more thing, the definition of the 6 trig functions. But once you have this unit circle copied down, you can bring it to class, and we're going to fill out the table. Okay, and we're going to answer the questions in section 28. Okay, so there's one more thing I need to show you. So let me clear everything here. Okay, so let's define sine and cosine. Sine of angle x is opposite over hypotenuse. So what do I mean? What do I mean by that is, let's say you have a right triangle, okay, and we call this angle x. That's my opposite, and that's my hypotenuse, okay, and that's my adjacent. So sine is opposite over hypotenuse. So since originally this hypotenuse was 1 on the unit circle and opposite was 1/2, okay, so 1/2 over 1 is going to give me 1/2 for sine of a 30-degree angle, if that turns out to be 30 degrees. Okay, so my angle could be anything other than 30 degrees. So for right now, we're just going to call opposite. Okay, over hypotenuse. So let me erase 1/2 and 1, so you're not too confused here. Okay, then we have a definition of a cosine. Cosine is nothing more than adjacent side. It's a ratio between adjacent side and the hypotenuse. Okay, adjacent means next to. And then tangent, okay, of an angle is nothing more than opposite ratio of opposite side over adjacent side. Okay, and then we have cosecant of x. Cosecant is hypotenuse over opposite. That's the ratio. And then secant is hypotenuse over adjacent. And then cotangent, which is my final trig function, is adjacent over opposite. Now if you look rather closely here, okay, tangent is nothing more than sine over cosine. Okay, that's another way of saying opposite over adjacent. And cosecant is nothing more than 1 over sine of x. All you have to do is flip the sign to get cosecant. And then secant is nothing more than 1 over cosine of x. So if you flip the cosine, you're going to get secant. And then finally, cotangent is nothing more than 1 over tangent. So when you flip the tangent, you're going to get cotangent. And pretty much that is the unit circle. Okay, those are the definitions. Some people, like this crazy word called SOHCAHTOA. And where does that come from? Sine, that is S. SOHCAHTOA. Sine is opposite over hypotenuse. So then cosine is adjacent, over hypotenuse. So tangent is opposite, over adjacent.